in introductory physics, there's a whole bunch of questions that are just like this one right here. And the question is basically, where in this particular place is the electric field 0? And there's a lot of different ways you could kind of formulate this. But if you have two charges, they're all kind of the same. They're all kind of the same. So I want to kind of show you every possible solution for where is the electric field 0. So let's get started. Let me switch over here to the paper, and this is going to be great. Turn that off. Where's my pen? Okay, so here is the problem. I have charge Q1 and Q2, and they're separated, right? I don't have to, I could put them anywhere, but I put Q1 at the origin and Q2 is not at the origin. They're separated by a distance s. So where is the electric field 0? First of all, if I have a charge, then I can calculate the electric field. It's a vector, and it points away from a positive charge and towards a negative charge. So this vector r is from the charge to the place I want to find the electric field. The magnitude of the electric field is 1 over 4 pi epsilon naught q over r squared. Now you may see that as k times q over r squared, where k is the same thing as this Coulomb constant. It's just a constant, it doesn't matter, and it definitely doesn't matter in this problem. Wait, does it? No, I don't think so. Okay, so, but this is a vector. E is a vector. So if we look over here, and let's just pick some arbitrary location, I'm gonna pick right here. And let's say this is a negative charge, and this is a positive one. But we'll deal with that later, but let's just pick that. Then right here, I want to find the electric field. Well, the electric field at that location is the sum of the electric field due to Q1 plus the electric field due to Q2. So let's say Q1 is red and makes a red electric field going this way. Right, because it's a negative charge to be pointing towards there. I think normally red is positive, but whatever. And here is a green charge, and it's positive, so it has an electric field going away. And they could be different magnitudes, who really cares? E2. So the sum of these two in this case would be the vector sum of these two, and it'd be this way. Okay, so could this vector plus that vector equal 0? And now we're technically talking about a 0 magnitude vector. So if I write this as a vector, you could write this E equals EX, EY, EZ. They have, X, Y, and Z components. The magnitude, if the magnitude is 0, then that would mean that the vector E is the 0 vector, which is 0, 0, 0. So it has to be 0 in all directions. The point is, up here, if I want a 0 vector, I'd have to have 0 magnitude. That means the x components have to add up to 0, the y components have to add up to 0, and the z components have to add up to 0. So there's no way that this can happen. The only way with two vectors to add them up and have a 0 value is that this x value would have to be completely opposite of that x value, which it's not. They're in the same direction. The y values have to be completely opposite. They might be in this case. And then the z values have to be completely opposite. Well, that's okay. In this case, it's probably 0, okay? But the only way you can have two vectors, vector A plus vector B equals 0, is if they're in opposite directions. So it has to be completely opposite, A and B. If they're at different angles, not going to happen. Can't happen, won't happen, not going to happen, okay? So anywhere up here, since the electric field due to E1 is pointing towards E1 and the electric field due to Q2 is pointing away, there's no way up here that they can add up to 0. There's no way. They're going to have different components. There's no way down here they can add up to 0. There's no way, right? Any place you pick a vector that's not on the x-axis, there's no way, because they're going to have different y components. There's no way that they can add up to 0. They're going to have different x and y components. The only way, even on a line perpendicular right here, if I'm down here, well, I could have Q1 as that way, Q2 as that way. Those don't add up to 0. What if they're both positive? When then it'd be like that. They don't add up to 0. They can't. The only way is on the x-axis. Okay, so with that being said, now I have three regions, A, B, and C, where the electric field could indeed be 0, and we'll start with location C. So let's say that I want to find the electric field, I want to find the x value over here, where the electric field is 0. Could it be 0? Yeah, it could be, right? Let's draw another picture, because let's start in region C. And then I'll do region B. Region A is actually the same as region C in some degree. Okay, so let's go back to our picture. You got to redraw it. Q1. I'm not saying whether Q1 is positive and negative. I'm just saying I have Q1 and I have Q2. So I'm over here with X. Okay, so let's find, this is the X direction. And again, I'm going to say this one's red and this one's green. And there's my location that I want to find the electric field, the X component, and that is a distance X. So remember, Ex is going to be equal to 1 over 4 pi epsilon naught Q over X, where the distance from that point squared. And if Q is positive, then if I have a positive charge, it's going to be in the positive X direction. If it's negative, it's going to be in the negative X direction, right? Because if in this region, not always, just in this region. So let's draw these. So let's say here's Q1. I'm going to assume they're both positive for now. So Q1 would make an electric field over here. I'll call that E1. And it's not a vector. I'm just drawing the magnitude of the X component. And then Q2 would make an electric field E2. So this total electric field, oh, not red, E would be E1 plus E2. And these are X components, so I'm not writing them as a vector. So that's going to be equal to 1 over 4 pi epsilon naught. And they both have that, so I'm going to factor it out. Q1 over X squared plus Q2 over not X squared. Because what's this distance right here? If this distance is X and this distance is S, this is X minus S. So this is going to be X minus S quantity squared. Now I want that to be equal to 0. I'll put want. Newtons per coulomb. So if I do that, I can solve for the location of X. Let's do that. Now remember, I have not said, you can see right here that if Q1 and Q2 are both positive, this is not going to happen. It's not going to have a 0 electric field appear. It's impossible. So let's just put that. Q1 equals negative Q2. And they're not even the same magnitude, but they have to be opposite charge. They have to be. Otherwise, it's not going to happen. Okay. Okay, so now that's why I don't need this constant right here, because I can multiply both sides by 4 pi epsilon naught, and it cancels, and I get 4 pi epsilon naught times 0 is 0. So I get Q1 over X squared plus Q2 over X minus S squared equals 0. I'm going to now subtract this from both sides, and I get Q1 over X squared equals negative Q2 over X minus S quantity squared. Now I'm gonna multiply this out, so it's gonna be negative Q2. Oh well, let me cross multiply. So you multiply both sides by X minus S over 2, and then multiply both sides by X squared. So I get Q1 times X minus S quantity squared equals negative Q2 X squared. Now I'm going to multiply this out, and I get Q1 times X squared minus 2SX plus S squared equals negative Q2 X squared. Now I'm going to add this to both sides, and I'm going to multiply this out, and I get Q1 X squared. Now I have this one, so I'm going to say plus Q2 X squared. Then I have this term, minus 2S Q1X. Then I have that term, plus S squared Q1 equals 0. And I want to solve this for what values of X make this 0. And you'll notice that I have a quadratic equation. So I can write this as, do I have room? I'm going to make room. Okay, so I'm going to put this as Q1 plus Q2 X squared minus 2sq1x plus s squared q1 equals 0. Okay, so now I have, this is a quadratic equation. Let me rewrite it again. q1 plus q2 x squared minus 2s q1 x plus s squared q1 equals 0. So this is x squared term, x term, constant term. So this is like a x squared plus b x plus c equals 0. That's the quadratic equation. So x equals negative b plus or minus the square root of b squared minus 4ac over 2a. And so at this point, I would have a value. I could say a is q1 plus q2. B is negative 2sq1. C is s squared q1. And so if I had an actual problem, which I'm going to do, I would have values for q1, q2, and s. And let's just check real quick here. And you can't have any value. It's not going to work for any values, right? It's possible, and in fact, I would say up here that in order for the electric field to cancel, not only do they have to be opposite charges, but this has to have a greater magnitude than that. Because look right here, if I want these two to cancel, then if this is going to be divided by a smaller amount, so in order for this to be equal to that, q1 has to be greater than q2. If q2 is greater than q2, this term's always going to be bigger than that one, and they'll never cancel. Okay, so let's do that. So I did that. That's my value. Let's switch over to Python, because I want to plot this. I want to do this two ways. I want to plot the electric field due to these two charges, and let's just pick some values. Actually, I already picked some values. I want to use the values I picked before because I know that it works. I'm going to pick q1 is 2 times 10 to the negative 6 coulombs. q2 is 1 times 10 to the negative 6 coulombs. And then s is 0.01 meters. I just picked some values. Doesn't really matter. So I'm going to plot the magnitude of the electric field as a function of distance and find out where it's 0. And then I'm going to use my quadratic equation and show that this is the same thing. Okay, so I'm going to plug in, oops, am I still on this? Yep. I'm going to plug in this and show that it's the same. That's a 0. Okay, so let's switch over here to Python. I got it all set up already because I'm on it. Okay, so switch over here. You can see that, right? I think you can see that. Okay. So let's just go ahead and make a graph. I'm going to make this as simple as possible. So t graph equals graph. Let's go ahead and put the labels. X title equals x in meters. Y title equals E. Newtons per coulomb. Okay, I'm actually going to make 3 graphs. I'm going to make F1 equals G curve. What color did that curve? What color did I make charge 1 was red? So let's put color equals color dot red. F2 equals G curve. Color equals color dot green. And then FE equals G curve. Color equals color dot blue, just for fun. That's the total. Oh, and then let's say K equals 9 times 10 to the 9th. That's my Coulomb constant. I need Q1 equals negative 2e negative 6. Q2 equals 1 times 10 to the 6th negative S equals 0.01. Okay, so what I'm going to do is I'm going to first calculate the electric field at different locations. Notice that I want to stay in region A, so I have to have X greater than 0.01, and I don't want it to be right at 0.01. So let's say X equals 0.02. Oops, 0.02. That's where I'm going to start. If I get too close to that first charge, the electric field goes really large. I don't want to do that. And now I need a dx. Let's put dx as 0.01. This is the step size. So I'm going to calculate the electric field at 0.02. And then go to 0.021, then 0.022, and so forth. Okay. Okay, so now I need to make a loop because I don't want to type that out manually. While x is less than, let's say, 0.06. So once it gets up to that value, I'm going to stop. And we can change it if we need to. I'm going to calculate the value for E1. And this is a scalar. E1 equals k times Q1 divided by x squared. In Python, squared is star star. Okay. Star star to the 2. E2 equals k times Q2 divided by x minus s squared. Now notice that I did not say negative or positive because that's built into the charge. Q1 is negative, so E1 is going to have a negative value. I don't have to put that in. Okay, now, and then E equals E1 plus E2. Now I just need to plot everything. So F1 dot plot x E1, F2 dot plot x E2. Oops. I didn't even save this yet. That's how I like to live dangerously. Fe dot plot xe. Now I need to increase the value of x, or the loop will go on forever. X equals x plus dx. And now I will save it. Where e equal 0, 1. Because I'm going to do another one. Save it. Let's run it. Check that out. See, sometimes I impress even myself. So here the electric field due to the green, here's E1, it has a negative x component, and this is the other one. And you'll notice here that it does cross the x-axis. So let's do this. If I go up here to graph, and I say fast equals false, and now I run it. It will use the Plotly engine for graphing. Now I can actually just zoom in on this region. And you'll notice here's the E equals 0 right there. So what's the value of x right there? 0.0, it's kind of, we can zoom in more. And I get, right? Oh, it doesn't have a value. That's the data point. It's just hopping to the data points, I think. Well, it looks like around 0.34 something. 0.034. That's the location. Okay. Excellent. Now, let's go over here and do it the other way, the quadratic equation way. So I'm going to say, I'm typing in my equations. A equals Q1 plus Q2. And remember, Q1 is negative. B equals negative 2 times S times Q1. C equals S squared times Q1. And this, yeah, that's fine. So now I can say x calc equals negative b plus or minus, let's do plus first, plus the square root of b squared minus 4 times a times c, all of that divided by 2 times a. And this is what's awesome about using Python as a calculator. I can write the equation. I don't have to put all those variables in my equation. I can say a, b, and c, and then to say, well, it knows what a, b, and c are, so I don't have to worry about it. And let's print xcalc. And we could make that nicer. But I'm not going to make it nicer because I don't care. Okay, let's run it. And there I have something that's different. You see, this is different than that number. And in fact, I can even make x let's make it a little smaller. I don't think it matters. But you see there, 0.35. It looks like 0.35. And that's way smaller than 0.035. So what's going on there? Well, the quadratic equation gives you two values. So let's try the minus. There you go. Boom. The same thing. It works. Pretty awesome, huh? Okay, let's go to region B. Okay, switching back to here. I need another piece of paper. Okay, yeah. So let's just start with this picture. Let's think about region B. In region B, I'm going to, what would have to happen for the electric field to be 0? Well, you have to have one electric field going that way and one going that way. So these two have to have the same charge. If they have opposite charges, if Q1 is negative, it would make an electric field going that way. So let's do that. Here's negative, positive. So if I have, this is red, and the other one is green, then here is, and I picked some location inside of here, this would be E2, and this would be E1. They're in the same direction. There's no way they're going to cancel, okay? And the same is true if I flip these, and they'd both be pointing that way. Now, if they have the same charge, if I have, let's say, negative and negative, then I pick this location. Here's E1 due to this charge is that way, and then here's E2 pointing that way. So it is possible for them to cancel. So they have to be the same charge. If it's in the middle, it has to have the same value of the charge. They have to have the same sign of charge. Now let's find out where that would be. So again, I'm going to say here's Q1. I'm going to assume they have the same charge. So they're both positive. And then here I want to find the electric field at some distance x, and this distance is s. So I can find E1. It's going to be 1 over 4 pi epsilon naught. And then it's going to be Q1 over the distance, which is x squared. E2 is going to be 1 over 4 pi epsilon naught negative Q2, right? Because this is the x component. It's in the negative electric x direction. And then this distance is going to be x minus s. It's actually s minus x, but it doesn't. S minus x squared. And then these two have to add up to 0. So E1 plus E2 equals 0. So I get 1 over 4 pi epsilon naught times Q1 over x squared minus Q2 over s minus x quantity squared equals 0. Yeah, I think we'll get so in this, if I multiply both sides by this, 4 pi epsilon naught, it goes away because there's 0 on the other side. I get Q1 over x squared minus Q2 over s minus x squared, and then equals 0. Add that to both sides, and I get Q1 over x squared equals Q2 over s minus x quantity squared, and then I cross multiply, which you can barely see, that's my fault, and I get Q1 s minus x quantity squared equals Q2 x squared. Now we're going to do the same thing. I'm going to multiply this out, and I get Q1 s squared minus Q1 times 2sx plus x squared equals Q2 x squared. Okay, so then let's just get this in a quadratic form. So that's going to be, I'm going to add this, subtract this from both sides, and I get, oh wait, what the heck? I left off my Q2, Q1. So I get x squared times Q1 minus Q2. Notice there's a big difference there. And then I get minus 2 Q1 sx plus Q1 s squared equals 0. So in this case, A equals Q1 minus Q2. B equals negative 2 Q1s, and C equals Q1s squared. Okay, so let's put some values and actually calculate this. So let's say this is 1 times 10 to the negative 1 times 10 to the negative 6 coulomb, and this is 2. And so I want to let's make the same graph in the middle, in between here. So let's switch back over to Python and switch it up and see what happens. So Python is here. So I don't have to, I'm just going to change Q1 to positive. And then I'm going to change this. I'm going to start off X at, the distance between them is 0.01. So I want to go, let's say 0.05. And then I don't want to go up to 0.01. So I'm going to say, well, it's, let's make this even smaller. 0.5, really tiny. No, let's do 5. I don't know what I'm doing here. Okay, but I can't go all the way up to the other value. So let's go to 0.08. Let's see, so I can't, yeah. Let's just try that. Let's make this smaller. I don't know what's going to happen. It may be a disaster. Okay, so now E1 is this. And it'd be in the positive direction. I've already changed that to positive, so but this one I have to put a negative sign on there, right? That's the x component. And this should be actually s minus x squared, but it doesn't really matter because it's squared. And I'm just checking my notes. Yeah. And then plot everything, that should work. Now down here I get a equals q1 minus q2. And then b is still negative 2 q1 s, and then c is just checking s squared q1. Okay, so let's see if that works. Okay, yeah, it looks like it works. So wait, no, which one is, no, this is the electric field right here. So I'm looking at this point right here at 0.0038, and I got not the same value down here. But again, we have two values for the quadratic equation, plus minus. And look, oh no, it didn't work. Why didn't this one work? This looks good, right? This says 0.0038. So A is Q1 minus Q2. Check. B, negative 2 Q1S, negative 2 Q1S. C is S squared. Maybe this should be minus. This is 0.005, 0.003. Okay, let's just change this time step to something smaller. It could be, that could be the problem. Let's zoom in. We're down here, I'm sorry, we're over here. That's where we're at. Okay, so it's working. I was looking at that line. This is the origin over here. So we're looking, yeah, that looks better. So right there. Okay, it's working. Check. Okay, now let's go back over here real quickly to the paper view. What about region A? Region A is just like region C, right? You're outside two charges. So if you want that region, it's the same thing, really. You'd have an x plus an s over 2, plus an s, but the math is the same, and I'm kind of bored with that right now. I don't want to do it, and you can't make me do it. I'm not gonna. Okay, so I'm gonna stop there. Where is electric field 0? It could be here, it could be there, it could be there. It depends on the charges, and that's how you find it. Okay, I hope that was useful for you. I enjoyed it just because of the Python stuff, and I will talk to you later. Bye.